This is the third session of Kubernetes Securities Deep Dive, and previously we did two sessions on Kubernetes security. We discussed about the API auditing, and we discussed about the quota and resource limit in namespace. So today we are going to discuss a very important topic about pod security admission. By default, when we allow some user, role-based access control-based user, any user to create the pod. So those users can misuse the pod to gain the advanced level of privileges uh, on the cluster host wherever they can schedule their pod. So first of all, I will show you what type of security weaknesses by default a pod have and how a user can gain those advanced level of privileges and can make some damages on your host level where the pod is running on your cluster. So here I have an example, a pod trying to run as a root user. I pull down this image from Docker Hub. Normally we use nginx image, and by default nginx image is using the root user. But uh, it is not a good practice to use the any container with the root privileges. And the best practice is to use a non-root user within our container. So here is my Kubernetes cluster up and running. kubectl get nodes, it's active. So let me just quickly run kubectl run just like pod one. I can give name hyphen image. And this is the image I am using. So this image will use a non-root user. Not it will not use a root user. And I want to use it in, for example, I can say in a UAT namespace. Okay, kubectl get pod hyphen and UAT. So here you can see it is trying to create the pod. It is trying to pull down, and when this will be created, I will show you that the user used inside this image is using a non-root user. So kubectl execute hyphen it and pod in the UAT namespace. I ran the command who am I. Okay, I am nginx. What is my ID? My ID used to run this nginx process is nginx user and 101. Normally, when we run the pod with the simple nginx image, it uses the root user. So you recommend this image, you provide this image to the developer, but there are some special security context that anyone who has access to your Kubernetes cluster and who can run the pod, they can use these security context in the pod creation manifest. So here, this is the security context section, and here they can use the allow privilege escalation to true, and you can set to run as non-root to false, and you can provide your own user ID and that will override the default user defined in the image. So when you build the image with the Docker file, there is a user uh, parameter we use to define the user that will be responsible to run the processes on the container, but we override that value by using this one. So if you want to understand the security context, so there are a lot of settings coming under the security context. So if I show you in the documentation, Kubernetes, you can see configure the security context. So configure the security context for the pod. So just read this documentation and you will get the idea how we can use the security context. We can define the run as user. We can force a pod to run with specific ID. We can force a pod a container to use this ID as a group ID, this ID as user ID, and every file created on the container will be by using this user ID. And here in the again in the security context under the container, uh, this is the pod level on all the containers. This policy will apply, and on specific container security context applied to allow privilege escalation to false. So just read this documentation, you will get the idea. I will do some other sessions too to explain you how exactly these are working, but here you can get the idea how this privilege escalation syntax, security context syntax is working. So, okay, so now we we create a container and it is running as a root non-root user. Now, anyone who has access, role-based access on your cluster to create the pod, what they can do, they will create the manifest just like pod. I can do it name with root user. So here I just create this manifest for this is the name of the application. I just give the name to app4. It's going, it will be under the UAT namespace and it is using this image. And here security context, by using the security context, I allow privilege escalation mean this pod can gain the higher level of privileges to true and run as non-root user to set to false, mean it can use the root user, and run as what user ID you can specify, user 0. So this is not mandatory, run as non-root user. If you remove this one too, you can simply define the run as user 0. So 0 ID you know is used in Linux for the root user. So let me just create this pod and in the UAT namespace, you can see the pod is running. And if I do kubectl execute it f4 hyphen 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 UAT, who am I? So this time the same image is used, and but it is running with root user. But previously, when I use without privilege escalation, I you can see the pod 1 I ran with the same image. It was using the nginx. So the user has access on the cluster to run the pod. They can use these security contexts to alleviate the privileges. Okay, and if I show you it's a root and its ID, you can see its ID is 0. So the image by default was using a non-root user as nginx, but we override those values by providing our own privilege escalations. So now this is one issue I showed you how a user can use the higher level of privileges. Okay, another example I will give you. A pod trying to gain host file system access. We discuss in detail about host path when we discuss about the volume mounting with the container. So I'm creating a pod that is trying to map the host path. This container name I gave insecure pod, I can say this, it's insecure pod, and the namespace I will give namespace to UAT. And again, I use the same image, and I use a privilege escalations, and I gain the root user level of access on the container. And I also did an activity that I am going to mount the root file system from the host machine, the worker node that will be responsible to run this container, and it will be mounted under the slash host slash root location of the container. So you can see the whole file system under this path inside the container. So let me apply this. Sorry, I think I used the UAT. Okay, so let me just kubectl cat namespace UAT. Yeah, I need to remove this. Just forget about this, what I am doing. I will explain you why this happened. So actually I apply some policy on this UAT for the testing purpose namespace. That's why it was blocking to run this pod. So let me apply this again. This time it's created. What was the reason? I will explain you in this video. Now you can see kubectl get pod in the UAT namespace. You can see the insecure pod is created. Let me jump into this pod. kubectl execute-it UAT namespace. You can see bash. I think it will work. Yes, inside the bash, if I run df-h, you can see all the partitions are mounted. But this I mounted from as a host path. So if I go under this location, this is a complete file system that is actually available on my worker node. I can destroy anything. I can run into the proc. Okay, I can see all the processes IDs running, what is happening on my host base machine. Okay, everything is available for me, and I can go under the etc. All the configuration files on the worker node is reachable to me. I can show you, for example, host name file. You can see this is my worker node one. So there are a lot of things that can be uh, compromised on your host machine by using this practice. So now there are thousands of scenarios that can be used to damage this system. I am not going to explain you here. You can think about it yourself, but I just gave you the idea uh, how how to how the host path is dangerous to mount in the container. Now I'm coming out from the container, and So this was the second scenario I showed you, how host path can be connected. You can see everything from the host machine. Another example, a pod is trying to gain the container runtime. So another host path you can use, when you run the container D. So on the host machine, var run container D sock, I think it's created. Let me check on my host machine. If some container kubectl get nodes kubectl execute var run. So I believe there will be the container D. If I Yeah, you can see this is a container D directory and it contains the container D socket. So this is the socket file created by the service, and this contains all the information about your containers running on your host machine. So the concept I want to clear here is under the container D, the file name is this is the socket file created by the service started on the worker node to run the containers. So if I map this file var run containerd.sock, let me just put this path here, and mount path I can say this is a socket file, and you mount it in the same location within your container. So now what will happen, uh, within the container this socket file is available, and you can install the any container CLI, just like CRI and that will use the same socket. You can install the container D and CRI and you can list all the containers running on the host, and you can create your own containers on the host by using the socket file. You can see what is everything. Even you can destroy the existing containers running on. So this is the advanced level of privilege escalation that can be misused by someone who has the access on to create the pod. So now the question is how we can secure this, and how this pod security admission is able us to control the the such type of advanced level of escalation by the role-based access user or RBAC based user. So in the Kubernetes, you can see in the documentation. I just close these documentations. Let me just open pod security admission. Pod security admission, you can read in the documentation that built-in pod security admission enforcement. Okay, so Pod security admission labels for namespaces. It is basically working on namespace level. So when you can apply some specific labels on your namespaces, that will enforce that namespace to follow the strict security policy. Okay, so we can make the policy mode of enforce, audit, and warning. I will explain you how this is working and how we can implement this. So pod, if we so here are the security admissions labels. So these labels, basically we can apply these labels. These are the types of label we can apply on some namespace. By default, if I show you the label on the namespaces, kubectl get namespace, kubectl get namespace uat hyphen hyphen show labels. So you can see this is the by default label coming on any namespace we are creating. Okay, just like this is a database namespace. So by default, when we are creating this, will create this label. Okay, so we can apply the pod security admission by using the special namespaces. So if I apply this label on this one, first of all, I will explain you how many labels we can here enforcement security with namespace labels. Yes, here. So here there are label example. This is the example where baseline security standard with namespace label, and I want to show you. Yes, namespaces can be labeled to enforce the pod security standards. The three policies: privilege, baseline, and restricted. Okay, cover the security spectrum and the implementation of the pod security. So privileged, baseline, and restricted. Okay, so here these are all the same pages, same documentation. Security standards: privilege, baseline, and restricted. So the label we can apply on the pod, we can apply with privileged, baseline, and restricted. Privilege is unrestricted policy by default. If no label is assigned, it's by default is privileged. If we even make this label privilege, it will not control anything. Unrestricted policies providing the widest possible level of permission. This policy allows the non-privilege escalation. Baseline, minimal restrictive policy which prevents non-privilege escalation, allow the default minimal security policies. And restricted is an advanced level of security policy, heavily restricted policy following current pod hardening best practices. So let me implement all these. By default, right now the pod I ran is in the privilege situation. So I will apply the baseline and restrict it. So how can I apply? So here I can show you how to label your namespace. So to apply the label, this is a dry run. I don't want to run the dry run. Label namespace UAT, and I want to apply pod security enforced as baseline, and here I have to provide equals. So now it is labeled, and when I label, it gave me a warning that this UAT namespace contains a part that is mismatching, that is violating the policy enforcement as baseline. So there are three types of label I can assign with the baseline. I can enforce, I can put audit, and I can do apply the warning. Enforce will not allow to run any pod until it is not comply with the security policy. Audit will only give us the audit. Uh, in the API audit we did. So it will only report in the audit that this security breach is happening, but it will not block. And pod security, when we set the warning, it will give us the warning on the command line when some pod is applied on this namespace with some security issue. It will give you warning, but it will again apply. So these two will apply, but this enforce will not apply. Whatever is already running, it will not disturb that, but anything coming new in that namespace will not be allowed. So enforce, audit, and warning concept you got. Now we have to understand this baseline and this baseline and restricted. So right now what I did, I create sorry, database UAT namespace. UAT namespace, you can see I applied this label. Now it gave me message that right now the pod is violating. So kubectl get pod in the UAT namespace. Let me just clear everything. Delete pod. The UAT namespace, and I will apply. Let me show you the pod with host path. Okay, so this is trying to gain the root level access from the host machine. So let me apply this. Let's see what happens. kubectl apply -f, and it is not applied. It is giving us the error from the server, forbidden error when creating pod. Pod name is insecure pod, whatever I define in this manifest. The namespace I use the UAT. The forbidden violates pod security baseline latest. When I set on this namespace to at least comply with the baseline. Host path volume, and I am using this host root volume to map something that is not allowed. Okay, let me allow the second pod I created with root user. Let's see, is this able to run? Yes, this is able to run. So kubectl get pod -n UAT mean the baseline policy enforced. When I enforce the baseline policy, blocked it blocked the application running of any pod with host path mapping. But even though we can run the pod with root user. Let me just quickly show you again this app4 -n UAT, yeah, -n UAT, who am I, ID. It is running as a root user. Still, this is not a good practice to use the root user. So baseline will only restrict you with the host path to map on the container. So now anyone who is trying to access this UAT namespace with base host path volume will not be able to run any pod. So this is the first level of security we applied. So baseline, now you understand what is this. Now I will apply restricted. So I am going to enforce the restricted policy 2 on this namespace UAT, and overwrite is false. Already has a value baseline. We must have to remove that value, so I can use overwrite. Must be one of the privilege baseline. Okay, we can use kubectl edit namespace UAT, and directly we can modify here. We have to apply restricted. So either we can use the baseline or restricted. So I change this. Values were saved. No valid values were saved. I think I need to add it. I don't know what is the issue, but quickly I am going to fix it by removing it, and I am applying by the command line. Sorry, this R is caps. Okay, now it's labeled. Directly you can even apply. So there I was doing a mistake with capital R. So now this is applied. So now it is giving you a warning that existing pods in the namespace URI violates a new pod security enforced level. Okay, so the existing pod are not comply the policy. App for allow privilege escalation is set to is not equal to false. It is set to true. And run as non-root user is not equal to true. So these are the issues it reported. Let me run the kubectl cat pod UAT namespace, and here this pod is not is reported. This is making these issues. So let me delete this pod and app4 -n UAT namespace, and let me apply kubectl apply pod with host path. It gave me the error. So baseline and restricted both are rejecting. Both are rejecting the host path. And if I apply the root user, so it is giving me the same error. So let me just explain you these errors in here. Because the command line, it is difficult. Let me segregate each error. So is forbidden. First one is violates pod security restricted latest. Mean allow privilege escalation is not set to false and must be set to this value. Okay, this was the first issue reported. Second is unrestricted capabilities. Container nginx must set security capabilities drop. All this is also a security context parameter we must have to set. These are the advanced level of capabilities this pod is trying to gain. And restricted volume type it is trying to gain the host volume. This is also not allowed in the enforcement mode of restricted, and you are trying to run this pod with a root user. This is also not allowed by restricted, and you are trying to enforce some UIDs that is not allowed. Mean it will only allow the UID and the user that is used when this image was built by Dockerfile by using the user instruction. And this is a security seccomp profile. This is related to SELinux and SELinux and AppArmor. In further videos of security, I will explain you what type of this security. So today we just have to understand how we mitigate these error and how we can enforce the end user to comply with the standards. So even though you don't understand about all these parameters, but we will cover this in later sections. So now we have to make sure all these parameters true. So first of all, what I will do, I must have to with the root user. Okay, so let me just do vim and so here it's not using the host path. Okay, so first of all, I need to set it to false. Okay, so privilege escalation I enable to false, and run as root user, run as non-root user true. Okay, and I am going to remove this parameter. Let me just apply this again. Let's see what is reported this time. kubectl apply -f. So you can see this time it is reporting less policy violations. I mean, whatever we comply, but still we are violating the security context. It is not applied, dropped all, and seccomp profile is not applied. So I create a pod that comply all the requirements. So this pod. So at least we must have to implement all these security contexts, to make sure the security policies. So I'm just going to remove these. Okay, so here you can see non-root to true, and I enforce that to use this non-root user ID. It is not mandatory. It will use the default non-root user that is defined in this image. If you use this image, some image that is using the root user, it will again give you the error. So let me just delete this. Okay, so it will use a non-root, and when the image will run, it is already using the non-root. Okay, and it's false. Drop capabilities drop all, no advanced level of capabilities, and this is the SELinux and AppArmor related. So I will explain this in further security videos. So here, let me now apply this. One thing I have to check what space it's using. UAT. Okay, it's using UAT. So here it's created now. kubectl get pod -n UAT namespace. It's running, and kubectl execute it f4 UAT namespace ID, you can see it's using nginx. Okay, let me do one more thing quickly. For example, now I must have to write this security context with every pod. Okay, whatever I am going to create a deployment or whatever I am using. So if I use here some image that is by default using the root user, let's see what happens. And I'm just changing this to F5, F5, in the UAT namespace. Rest of all is good. kubectl apply. It's created. kubectl get port -n UAT container create config error, and I believe kubectl describe port F5 in the UAT namespace. So success container has run as non-root and image will run as root, so that's why it will not allow to run. So the enforcement and restricted pod security admission actually make sure from you in the manifest that you must have to use these things, this security context. So since this image is not comply with this one, so that's why this container will not run. You must have to use a non-root user inside your image. Now you will create the new Docker file and you will use the different image or whatever you can do. So this was the concept of baseline and restricted. And now you know how to apply the label and how you can use these labels to apply on your on your namespace to make sure these security policies. So let me do one more thing. Let me apply restricted a warning. So let me apply this kubectl edit namespace UAT. You can do by command line too. Here I am just going to, so give me the warning too. So now this time let's see if I apply, if I create a container with some user is trying to use privilege escalation to true, okay, and want to use root user, okay. So now, and let me just change to F6 because F5 is already running. kubectl apply -f. You can see it is giving me the error. Okay, so warning message will give me the warning when I will apply any pod that is not compliant. So this was the topic for today. You must have to read these documentation to get the better idea how these policies are implemented, and how to relabel the namespace, and what are pod security standards, and what is security escalation in pod.